Optimization problems. One of the most important applications of derivatives occurs in the solution of optimization problems, in which a quantity must be maximized or minimized. So some examples include trying to maximize an area or a volume or a profit, or if you're trying to minimize distances, time, cost. We sometimes call these maxi-min problems, as in maximization, minimization problems. Optimization encompasses both of those meanings. So in solving these kinds of problems, the first step is to set up the function that you need to maximize or minimize, and then you use your derivative to find your absolute maximum or minimum. We'll do several examples. I think you'll get the idea. When you're solving word problems, I'd like you to be really careful to always provide a key to your problem and identify what your variables represent. Find two positive numbers whose product is 10,000 and whose sum is a minimum. So we need to find a way to minimize the sum. So find two positive numbers. Let's just start by saying, let x be the first number and y be the second number. Okay, what information have we been given? Here's one piece of information. The product of those two positive numbers, x, y, are greater than 0. The product, that means when I multiply them together, I get 10,000. My goal here is to minimize the sum. Sum meaning when I add those two numbers together, I get what? I'm not sure what I get, but I want this to be the smallest number possible while meeting that condition. So x plus y equals s is what we wish to minimize. Okay, so let's look at what the pieces of information we have. We can solve this equation for y and substitute it into here, like so. Y is equal to 10,000 over x. Then every time I see a y in this equation, I just substitute in my other piece of information. That is x plus y, 10,000 over x, is equal to s. So since I wish to minimize this function, that means I want to know the critical numbers. So in order to find the critical numbers, I'm going to take the derivative. And since I'm taking the derivative, I'm going to start by writing this in the easiest form in which to take the derivative. So what's s prime? Well, s prime is equal to 1 minus 10,000 x to the minus 2, or 1 subtract 10,000 over x squared. And since I'm looking for the zeros of this, let me just give these a common denominator. 1 is the same as x squared over x squared minus 10,000 over x squared. There's my derivative. What are the critical numbers? Well, the critical numbers are the values that make the derivative either 0 or undefined. Well, it would be undefined if my denominator were 0, or if my numerator were 0. X squared equals 10,000. X equals plus or minus the square root of 10,000, 100. Okay, look back up to the domain. X and y both have to be greater than 0, so that one doesn't count, that one doesn't count. We've just got x is equal to 100. So then we are asked to find both of those positive numbers. If x is 100, what's y? Substitute your x value back into your equation and solve for y. Answer the problem with a sentence. The two numbers are x equals 100, y equals 100.